Hello everyone. In this video, we are about to discuss about the topic of atomic structure. Atomic structure. See, in this when we came across with the atom concept of atom, we will deal with three things. First one is proton. Second one is neutron. And third one is electron. The combination of proton and neutron yields to nuclei. The combination of proton and neutron yields to nuclei, which is normally known as nucleus. Nucleus, which is at the center of the atom. So, at the center of the atom, most of the mass is existed in the center of the atom, and the electrons are revolving around the nucleus. See, the concept of proton and neutron and electron is discovered by some of the scientists, and we have to remember that names. And a proton is discovered by Goldstein, and the neutron is discovered by Chadwick, Chadwick. Okay, and the electron is discovered by J.J. Thomson. Okay, J.J. Thomson. Okay, so in this concept, we will come across with the terms like mass and charge. Okay, so mass for the proton and neutron and electron is defined in two terms, in normal SI units and in another units electrostatic units. So in normal SI unit it is defined as in kilograms. In charge perspective, atomic mass unit. Okay, then the charge is considered in three parts. One is relative charge with respect to neutron. What is the charge of the proton and electron is defined by relative charge. Another unit of charge is coulombs. Another thing is coulombs, and the last unit of charge is electrostatic unit. Okay, we have to consider these aspects, and we have to remember each and everything. Units: mass is defined as kilogram and atomic mass unit. In terms of kilogram and atomic mass unit, kilogram is unit of conventional method of SI units, and the charge is defined as in terms of three things. One is relative charge. Relative charge specified in terms of neutron. How much charge is accumulated with respect to neutron is defined as relative charge. So if we consider the mass of the this is electron and this is proton. So if we consider the mass of the electron, neutron and proton in terms of SI units, kilograms, we will know that the electron mass is 9.11 into 10 power minus 31 kilograms, which is very little bit of mass, and the most of the mass is existed in the neutrons and protons. The mass of the neutron is 1.627 into 10 power minus 27, and the electron is 1.6 and the proton is 1.675 into 10 power minus 27. Most of the mass is accumulated with these two elements, neutron and proton. Why? Because these are existed in the nucleus and the electron is revolving around it. And the atomic mass unit of the electron is far little less. It is 0.005486 atomic mass unit, and the neutron and proton atomic mass is closer to 1. It is very closer to 1. Not remember to overall thing. It is close remember to 1. And if we consider the charge of the electron, neutron and proton in terms of three parameters. First one is relative charge. So neutron has no relative charge, it is 0. Neutron has no relative charge, it is 0. With respect to neutron, electron has negative charge, and with respect to neutron, proton has positive charge. That thing we have to remember. Neutron has no relative charge. Relative charge of the neutron is 0. With respect to neutron, electron relative charge is -1, and with respect to neutron, proton charge is positive. Okay, so charge negative indicates the electron charge, and positive indicates the proton charge. Whenever if we comes sign convention, we have to remember this concept. And the charge in terms of coulombs is the neutron charge is absolutely 0, and the electron charge is negative some value, and the proton charge is positive some value. Both are the same values but quite an opposite. 1.602 into 10 power minus 19, 1.602 into 10 power minus 19. Both are the same values but opposite signs. For the electron it is negative, for the proton it is positive. And the another thing is electrostatic unit, ESU. With respect to Newton has electrostatic unit has 0 value, and similar to this concept, electron has negative charge, and proton has some positive charge having same value. These are quite opposite to each other. So here the value is electrostatic unit for electron is 4.8 into 10 power minus 10, and here 4.8 into 10 power minus 10. Both charges are same, but the signs are different for the charge perspective. This entire thing we have to remember in order to do the calculations in atomic structure, in some sort of things. Some problems will also come directly by asking the what is the electrostatic unit of electron, what is the Coulomb charge of electron, what is the relative charge of neutron, like that. So we have to remember all these things. Consider the atomic mass unit of the electron is absolutely near to 0, but it's not to 0, and the neutron and proton has relative atomic mass unit is near to 1. And the another thing we have to consider is the electron mass is equals to 1 by 1837 times of proton mass. Why? Because electron has very little mass and the proton has very large mass. So if we divide with 1837, we will get the approximate mass of electron. And the another thing we have to consider is specific charge. Specific charge. See, the ratio of charge to mass is known as specific charge, and it units as Coulomb per kg. So if we consider this thing also, the specific charge of neutron is 0, and the specific charge of electron is 1.76 into 10 power 11 coulomb per kg, and the specific charge of proton is 9.58 into 10 power 9.58 into 10 power 7 coulomb per kg. These things we have to remember. And the next concept we have to look at in this atomic structure is atomic number and the mass number. Atomic number and mass number. So you know that the number of protons or number of electrons present in the nucleus, present in the atom, is known as atomic number. Okay, and the mass number is sum of protons and neutrons, is known as mass number. Why? Because mass is existed in the center of the nucleus, so that's why the most of the mass is existed in the nucleus. The nucleus consists of proton and neutron, so the combination of proton and neutron yields to the mass number. And the atomic number, either we can take proton number of protons, or we can take the number of electrons. It is the concept. So if we write atomic mass number as A, that means A equals to P plus N, and the atomic number is represented by Z. So here we can take the proton number as Z. So if we substitute Z as in this here, we will get A equals to Z plus N. That means number of neutrons equals to A minus Z. So that means number of neutrons equals to mass number minus atomic number. This is a formula which we have to remember. Number of neutrons equals to mass number minus atomic number of the atom. Take an example. Sodium has atomic number as 11 and the mass number as 23. So we can say that number of protons is 23 minus 11 in this formula. So Z equals to number of neutrons equals to A minus Z. So that means A equals to 23 minus 11. So that means we got 12 neutrons. In the sodium atom we got 12 neutron atoms.